It says that when an eccentric load is acting on a column, it produces direct stresses as well as bending stresses, as we have studied earlier. So if the direct stresses are more than bending stress, means that sigma d is greater than sigma b, then the stress throughout the section will be compressive. Okay, then stress throughout the section is compressive. But if the direct stress is less than the bending stress, there will be tensile stress. Then there, bye bye. But we know that concrete column are weak in tension. We know that column are we can say concrete column are weak in tension. Therefore we have to apply load in such a way that there is no tensile stress in the section. So not to be permitted tensile stress, बेंडिंग स्ट्रेस या तो लेस हो या फिर इक्वल हो डायरेक्ट स्ट्रेस के. इन सच केस or in other word we can say that bending stress is has to be less than or maximum to maximum it should be equal to direct stress, but it cannot be more than direct stress. So if I am providing a bending moment, see there is it's very evident that the more the bending stress, I am trying to rotate this pen. If the bending stresses are more than this direct stress, then there will be more tension in the member. But we know that column is not a tension member, it is a compression member. We design our column as a compression member. So it is not a viable thing to have more bending stresses in our column. So it's better that we keep it as minimum as we can. So what we can do for that is that we need to minimize those bending stress. Bending stress has to be less than the direct stress, or maximum to maximum. If there is certain cases, then we could uh, we could keep both of them equal. In that way, in that case also, there will be no tension in the section. So let's see. Now we will see limit of eccentricity in for a rectangular column. This is our column. It has a base width of B, or width has D, what middle third rule says is that the load must act within B by 3, but now we are going to determine it. So firstly we will calculate the IYY for this section would be dBq by 12, and section modulus for the same would be IYY upon YY2. So IYY we have dBq by 12, and for this we have y by 2 means b by 2. So our z is dB square by 6. So now we want sigma bending stress to be less than or equal to direct stress. So we have just calculated our bending stress. Bending stress is sigma bending, just doing some rough work. M upon I is equal to sigma upon Y. Sigma B is equal to M is equal to into Z. So M over Z is equal to sigma bending. Let's put the value over here. M upon Z is less than equal to चल